Hello everyone, this is Priyanka K studying at Sri Venkateshwara College of Engineering. Today in this video we'll be looking into computer network architecture. Firstly, we'll see what is a computer network. Computer network is a group of computers connected with each other through wires, optical fibers or optical links so that various devices can interact with each other through a network. The aim of a computer network is the sharing of resources among various devices. In the case of computer network technology, there are several types of networks that vary from simple to complex level. Now we'll understand what is computer network architecture. Computer network architecture is defined as the physical and logical design of the software, hardware, and protocols of the transmission of data. Simply, we can see that how computers are organized and how tasks are allocated to the computer. Next, we'll see what are computer network models. A communication subsystem is a complex piece of hardware and software. Early attempts for implementing the software for such subsystems were based on a single, complex, unstructured program with many interacting components. To overcome such problem, the ISO has developed a layered approach. In the layered approach, networking concept is divided into several layers and each layer is assigned a particular task. Now we'll see what is layered architecture. The main aim of the layered architecture is to divide the design into small pieces. Each lower layer adds its services to the higher layer to provide a full set of services to manage communication and run the application. It provides modularity and clear interfaces, that is, provides interaction between subsystems. It ensures the independence between layers by providing the services from lower to higher layer without defining how the services are implemented. Any modification in a layer will not affect the other layers. The number of layers, functions, contents of each layer will vary from network to network. The purpose of each layer is to provide the service from the lower to the higher layer and hiding the details from the layers of how the services are implemented. Mainly, why do we need layered architecture? We need a layered architecture to divide and conquer approach modularity. It is easy to modify and easy to test. Firstly, divide and conquer approach makes a design process in such a way that the unmanageable tasks are divided into small and manageable tasks. In short, we can say that this approach reduces the complexity of the design. Modularity defines layered architecture is more modular. Modularity provides the independence of layers, which is easier to understand and implement. Easy to modify. It ensures the independence of layers so that in the implementation in one layer can be changed without affecting the other layers. It is easy to test because each layer of the layered architecture can be analyzed and tested individually. Layered architecture is one of the easiest structures to implement since every layer has its specific function. Testing is easy since layers can be marked. Flexibility in some sense, any software can be abstracted into layers. We use layered architecture when developing simple and small applications. Next, we'll move on to the digital transmission. Data can be represented either in the analog or digital form. The computers use the digital form to store the information. Also, the data needs to be converted in digital form so that it can be used by a computer. Now, what is digital to digital conversion? It is a process of converting the digital data into digital signal. Is called as line coding, which helps the receiver to get the original bits. The data that is in the form of text, numbers, audio, or video is represented internally as series of ones and zeros. It is a representation of digital information by a digital signal where ones and zeros generated by the computer are translated into a sequence of voltage pulses that can be propagated over a wire. This is known as digital to digital encoding. Digital to digital encoding is categorized into three types. They are unipolar, polar, and bipolar. Firstly, we'll see what is unipolar. Unipolar involves digital transmission system sends the voltage pulses over the medium links such as wire or cable. In most of the encoding, one voltage level represents 0 and another voltage level represents 1. The polarity of each pulse determines where it is positive or negative. This type of encoding is known as unipolar encoding, and it uses only one polarity. In this, ones are represented as a positive values and zeros are represented as a zero value. In unipolar encoding, 1 is considered as a high voltage and 0 is considered as a zero voltage. Unipolar encoding is simpler and inexpensive to implement. Next, what is multiplexing? Multiplexing is a technique used to combine and send multiple data streams over a single medium. The process of combining the data streams is known as multiplexing, and also hardware is used for multiplexing is known as a multiplexer. Multiplexing is achieved by using a device called multiplexer that combines n input lines to generate a single output line. Multiplexing follows many to one, that is, n input lines and one output line. Demultiplexing is achieved by using a device called demultiplexer available at receiving end. Demultiplexer separates a signal into its component signals, that is one input and n outputs. Therefore we can say that demultiplexing follows the one to many approach. Now, why do we need multiplexing? Because the transmission medium is used to send the digital signal from the sender to receiver. The medium can only have one signal at a time. When multiple signals share the common medium, there is a possibility of collision. So, multiplexing concept is used to avoid such collision. And also transmission services are very expensive. So, we use multiplexing. What are the advantages of multiplexing? There are more than one signal can be sent over a single medium, and the bandwidth of a medium can be utilized effectively. There is no need of synchronization between the sender and the receiver. Efficient use of resources, data compression, and data encryption.